Okay, in this second video we're going to take a look at some of the problems from section 2.3 that have a slightly different form. And here it has the absolute value of ax plus b plus c is equal to d. And we're going to see that we'll take one simple step to transform this problem into the same type of problem that we were working with previously. And all we're going to have to do there is subtract 2 from both sides before we begin. And we end up with the expression 3x minus 1 is equal to 3. Again, what that states is that there is a number, 3x minus 1, that is 3 units away from 0 on the number line. So that number could either be negative 3 or positive 3. And we set up two different equations from this. 3x minus 1 is equal to negative 3, and 3x minus 1 is equal to positive 3. We'll go about solving these exactly the way we did in the first two problems we did, and that is to isolate the x by adding 1 to both sides in each equation. On the left-hand side, we get 3x is equal to negative 2, dividing both sides by 3. We end up with x is equal to negative 2/3, and on the right side, dividing both sides by 3, we end up with x is equal to 4/3. Okay, so we should just double check that these are true, and you have to be careful about where you're going to plug that in. And we can either substitute x equals negative 2/3 or 4/3 into the original equation, which is in green at the top of the screen there, or the transformed equation, absolute value of 3x minus 1 is equal to 3. Either of those are okay. One is just a slight transformation of the other one before we started to work. So let's choose the easier one of the two, which is absolute value of 3x minus 1 is equal to 3, but we could use either one of them. And what we're trying to show is that when we substitute x equals negative 2/3 and x equals 4/3, that we get a true statement. That statement is true in either case. So if we start with 3x minus 1, absolute value of 3x minus 1 is equal to 3. We substitute x equals negative 2/3 and multiply that out. Well, 3 is the same as 3 over 1, and 3 over 1 times negative 2/3 is negative 6 over 3, which is negative 2. And so we get absolute value of negative 2 minus 1, which has to equal 3. And negative 2 minus 1 is negative 3. And we know that the absolute value of negative 3 is 3, so that is a true statement. When you plug in and solve or evaluate those expressions, and you get two sides that are the same, then that means you have a true statement. If you got two sides that were different, it would mean that you don't have a true statement. Okay, now we'll look at the second equation, or the equation plugging in x equals 4/3. So we have absolute value of 3x minus 1 is equal to 3, but x is equal to 4/3, so we get 3 over 1 times 4 over 3, which gives us 12 over 3, or 4, minus 1, and the absolute value of that is 3. And so that says the absolute value of 3 is 3, which we also know to be true. So plugging in x equals 4/3 into that equation also gives us a true statement. So that means we have two solutions to this equation, two values of x, two values that when we substitute for x will make that statement a true statement.